your homework from last night, worksheet number 7, vector addition. First couple of questions, pretty straightforward here. One-dimensional vector addition, stuff that you could have done really in junior high school. First one says 150 meters to the right, 100 meters to the right. The vector, some of those is just 250 meters to the right, or plus 250 meters. Second one, a little bit trickier, but not much. We've got 150 meters to the right, 100 meters to the left. We're just going to add these up like we did at the beginning of the year, like we did in junior high. 150 plus negative 100 gives me positive 50 meters, or 50 meters to the right. Easy enough, right? Well, question number 3 is where it starts getting like what we've done over the last few days. Here we've got two-dimensional vector addition, 20 meters to the east, 10 meters to the north. We already have a vector diagram drawn for us. This is drawn head to tail, so that's good. We just got to draw a resultant vector in here now, which is the sum of those two vectors. Remember, a resultant vector is not drawn head to tail. It's from start to finish, or head to head, tail to tail. We're going to label that R, and we're going to label our angle right here at the beginning of my vector diagram, theta. Now, the goal is to get a right angle triangle. Here, I already have one, so all we got to do here is to solve for R, the Pythagorean theorem. The square root of 20 squared plus 10 squared gives me a value of 23 meters. That's the magnitude of the resultant vector. And we'll solve for theta using the inverse tan function. Now, let's make sure you're in degree mode on your calculator. Get sine 90 to make sure you're in degree mode. Equals 1, sure enough, we're in degree mode. Now let's look at the inverse tan of opposite over adjacent. That's 10 meters over 20 meters. We figure that out. The inverse tan of second function tan of 10 over 20, we get a value of 27 degrees. 27 degrees. Now, this angle has to be measured from something. You can see in this case, I think, that it's measured from the east axis, but yet we go north from east. So we're going to say it's 27 degrees north from east, or 27 degrees north of east. Question number 4. 23 meters at 27 degrees north of east. Number 5 is pretty similar. Head to tail, the resultant vector goes from start to finish. Label it as R. Draw your angle at the very beginning of the vector diagram. And let's say R is equal to the square root of 15 squared plus 10 squared. That gives me, if I go to my calculator and do it, it will give me 18 meters, 2 digits. And theta, the inverse tan function of opposite for adjacent. Opposite in this case would be 10, because it's the one that's not touching the angle. Over 15, the adjacent side, that is the one that is touching the angle, but isn't the hypotenuse. So we solve for theta here, and it's going to work out to be 34 degrees. We're measuring it from the east axis, but yet we're going south from the east axis. So we're going to say this is 34 degrees south from east, or 34 degrees south of east. 18 meters, 34 degrees south of east. Let's take a look at number 5. Again, pretty similar here. Head to tail, that's good. Resultant vector starts to finish. We solve for R using the Pythagorean theorem. Square root of 5 squared plus 10 squared gives me a value for R of 11 meters. And theta, always going from the start of the vector diagram, the inverse tan of opposite over adjacent. It gives me a value for theta of 27 degrees. 27 degrees measured from the west, but yet south from the west. So 27 degrees south of west. 6 starts getting a little trickier here. We have 3 vectors, all drawn head to tail, so that's good. A resultant vector drawn start to finish. I can't just use the Pythagorean theorem here though, because I don't have a right angle triangle. We need to do that. We need to make a right angle triangle. So let's do that now. Let's say x components, y components. 10 meters for the first one, 0 meters for the y component for the first one, 0 for the second one for x, 5 for the y for the second one, 15 x component for the third one, 0 y component for the third one. We add these up, 25 and 5. Now let's redraw this as a simple right angle triangle. We have 25, we have 5. Our resulting vector is start to finish. We're going to solve for r in exactly the same way as we did in the last three questions. We end up getting a value of, to 2 digits, it actually works out to be 25 meters. In theta, the inverse tan function of opposite over adjacent, 5 over 25, is 11 degrees, and that would be north from east, or north of east. So our answer is 25 meters, 2 significant figures, at 11 degrees north of east. Number 7. Keeps getting a little trickier here. Here we have 4 vectors that we have to add together. Yeah, we don't have a right angle triangle, but we can make one fairly easily. We do that by breaking it up into x's and y's. 0 for the first one, -8 for the y component. 12 meters for the x component of the second one, 0 for the y component. 0x, 10y for the third one here. And -4 for the x component of the last one, and 0 for the y component of the last one. Add these up, you get a total of 8 for the x, 2 for the y. Now let's redraw it. Let's say 8 and 2. We've got a resultant vector that looks like this, which makes me notice that I made a mistake over here. This resultant vector should have been drawn from start to finish, not finish to start. And that makes it look a lot like the resultant vector that I just got on our right angle triangle. We're going to solve for r using the Pythagorean theorem. We get a value here of 8.2 meters. And we get a theta here, the inverse tan of 2 over 8. Opposite over adjacent gives me a value of 14 degrees north of east. We're measuring it from the east, but yet we're going north from the east, so we'll say north of east. Number 8, it's trickier still. Now we have a funny angle, and if you remember from a few days ago, whenever we see a funny angle like 30 degrees, or 72 degrees, or 19 degrees, or 89 degrees, we have a 5-word phrase that we always think of right away. I don't like funny angles. So we get rid of it. We take it off to the side over here, and we want to get rid of that funny angle, that 30 degrees. And we want to replace it with our vector components, our x components, and our y component. I'm actually going to change the color of this. Usually I end up drawing this red, although it doesn't really matter here. The x component of the first of that 40 meters is the adjacent side of the triangle. Adjacent and hypotenuse goes with cosine. Cosine 30 is equal to adjacent over hypotenuse, and x ends up being equal to 34.641 meters. The y component is the opposite side of the triangle. Opposite and hypotenuse goes with sine. Sine 30 degrees is equal to opposite over hypotenuse. The opposite side equals 20 meters. Now, I'm going to box this off. Just put it over to the side because it's just kind of extra to the question here. This is what separates it from, say, a question like number 7 or number 6. And now, I think what I'm going to do is redraw that 40-meter vector. It's not dead to me. I don't want to see that anymore ever again. I got rid of it. I converted it to 34 and 20. So let's label that as a 34.641 and a 20 down. I'm just going to scratch out the 40 meters at 30 degrees. It's gone. replacing it with an X and a Y. Now, let's do what we did in question 6 and 7. I'm going to say 80 meters for the first vector, 0 meters on the y-axis for the first vector. 34.641 meters for the x component of the second vector, 0 for the y component. 0 meters for the x component of the third vector, negative 20. Negative because it's downward. Negative 20 for the y component. Add these up. It gives me 114.641. This one adds up to give me negative 20 meters. Now, let's draw our right angle triangle. 114.641 and negative 20. I don't actually need to draw the negative in there because the arrow shows the direction. It doesn't be comfortable. Let's calculate the resultant vector. Same way as we have for the last number of questions. It's the square root of a squared plus b squared. Its value ends up being two significant digits, 1.2 times 10 to the 2 meters. Theta is the inverse tan of 20 over 114. That gives me 10 degrees. But we're measuring that angle from the east, south from the east, or south of east. I should have drawn my resultant vector up here. You can see that it looks a lot like the resultant vector in my right angle triangle. It should look exactly the same if I had it drawn to a perfect scale. Now let's take a look at question number 9. We also have a funny angle here in question number 9 that we got to get rid of here. So let's take that 30-degree angle off to the side. Let's draw my x-axis, or my x component of that 30. Let's draw my y component of that 30. The x component is the adjacent side, adjacent and hypotenuse. We'll say cosine 30 is equal to adjacent over hypotenuse. X ends up being equal to 43. It's actually negative 43.3013 meters. And the y component is the opposite side. So we'll say sine 30 degrees is equal to opposite of hypotenuse. And that ends up being equal to 25. It actually is negative as well because it's downward. They're both negative. First one's negative because it's to the left. The second one is negative because it's downward. Now, I'm going to replace this 50 meters with a 25 right there and a 43 right here. And now I'm going to just get rid of this because I've always said once we get rid of that funny angle and the vector at that funny angle, we never want to use it again. It's gone. It's dead to us. So we'll say now x, y, 0, negative 50, negative because it's downward. The x component of the second one is 75. The y component is 0. 0 for the x component right here. Negative 25 because it's downward. And the x component of this last one is negative 43.3013. And the y component of that last one is 0. We add these up. Use your calculator for this. 31.6987. And this adds up to give me, this one's easier, negative 75. Let's redraw this. We got 31.6987. We got negative 75. I don't need to put in the negative now because the arrow shows that direction. And my resultant vector, again, I should have drawn it up here just to compare. Sure enough, it looks pretty much like it did in the original diagram. So let's solve for r. The hypotenuse, square root of 31 squared plus 75 squared, it equals 81 meters. And theta, always going at the start of the vector diagram, is the inverse tan of 75 over 31, opposite over adjacent. and it gives me 67 degrees. And that's measured from the east, but yet we're going south from the east. We're south of east. And finally, the last question here, question number 10. Here we have two funny angles. I especially don't like two funny angles. We got to get rid of them both. Let's take the first one, 5 meters at 60 degrees. Let's label the x component, and let's label the y component. Now, the x component this time is the opposite side of the triangle. Opposite, and I thought this goes with sine. Usually, x goes with cos, but in this case, it goes with sine. Sine 60 is equal to x over 5. X ends up being equal to 4.3301 meters. And the y component is the adjacent side, so we'll say cosine 60 degrees is equal to y over 5. That's going to be equal to 2.5 meters there. We're going to box that off. Maybe even replace this with 4.3301, this with 2.5. Let's scratch this out. It's gone. 5 meters is dead to us now. We've completely replaced it with 4.3 and 2.5. But now I also have another funny angle. That's that 10-meter vector right there. Let's draw that one over here. Kind of running out of space here, but we'll see that's 10 meters at 30 degrees. Let's use a couple different colors this time. Let's go purple, X, and let's go yellow, Y. The X component of this 10-meter vector is the adjacent side. We'll say cosine 30 degrees is equal to adjacent over hypotenuse. X ends up being equal to 8.6603. And let's say the y component, sine 30 degrees, is equal to opposite over hypotenuse. And the y component, the opposite side, is 5.0 meters. We're actually going to make that y component negative though, because it's going downward. Let's draw the x to replace the 10. And let's draw the y to replace the 5. And now let's erase all this. Because remember, once we resolve it into x and y, the original vector at the funny angle is dead. Finally, we're back to the old x and y components. Negative 10 and 0 for the first one. 0 and negative 10 for the second one. 4.33 and 0 for the third one. 0 and 2.5. The fourth one, 8.6603. The fifth one, along with 0 for the y component. And we'd say for the x component of the last one, 0. And for the y component of the last one, we'd say negative 5. Add those up. Use your calculator if you want. 2.9904 meters, negative 12.5 meters. Let's say 2.9904 to the right, 12.5 meters down because it's negative. And that resultant vector is going from start to finish with the angle right up here at the start of the vector diagram. Finally, we're almost there. Let's say r is the square root of a squared plus b squared, using a value of 13 meters. And last but not least, theta is the inverse tan of opposite over adjacent, which ends up giving me 77 degrees. 77 degrees measured from the east, but yet south from the east. So we'll say 77 degrees south out east. That's it.